Perform and complete a full two-population hypothesis test for proportions. P-value approach. A survey of American adults asked participants to agree or disagree with the statement. Gender equality in this country is better now than it was 50 years ago. The results are shown in the table below. Let P sub 1 be the proportion of males who agree with the statement and P sub 2 be the proportion of females who agree with the statement. Is there enough evidence at alpha equals 0.05 to conclude that the proportion of males is greater than the proportion of females who agree that gender equality is better now than it was 50 years ago? Work through the test procedure and interpret the results of the hypothesis test. Before we do that, let's refresh ourselves on those 5 steps. First, we're going to identify the null and alternative hypothesis. We'll decide on the significance level. We'll compute the test statistic and use that to find the p-value, and then we'll interpret the results of the hypothesis test. Let's identify the null and alternative hypothesis. So remember that the null hypothesis includes the equality statement, while the alternative hypothesis includes the inequality. That could be a less than, greater than, not equal to. In this particular case, we are looking for a higher proportion of males than females, so that higher proportion tells us it's a greater than sign, with the males as the first sample. So proportion of males greater than proportion of females. That makes our null hypothesis P sub 1 equals P sub 2, where the proportion of male and the proportion of females being equal. Higher proportion will tell us that the alternative hypothesis is P sub 1 is greater than P sub 2. Let's move to part 2, deciding on the significance level. We are given the significance level in our question. We know that alpha is 0.05. Now computing the test statistic. Anytime you are finding the test statistic, it makes the most sense to write the formula down first. So in this case, we have the sample proportions here of males minus females, and then we have the pooled. Remember, the pooled is where you're putting the females and males together. So using the given information we have, we can find the proportion of males, p hat sub 1, 162 divided by 200. For females, 148 over 200. And then for pools, we add male plus female over the 2 sample sizes, and we have the values accordingly. Once we have that information, we can go ahead and substitute into the formula. It is important. I think it's very important to start with the formula with symbols. We know we're using a z-score. We've got the different values that we need, so we can easily substitute into that formula and hopefully make fewer mistakes. So once you plug everything in, please make sure you're using parentheses when you plug this into your calculator. You want to make sure you're following the order of operations. And we end up with a test statistic of 1.68. Now we can use that test statistic to find the p-value. So to find the p-value, we're going to use that z-table using 1.68 as the z-score. It's a right-tailed test because of that greater than sign. So the area to the right of 1.68 is going to be our p-value. From the table, we know that always gives us area to the left. So the area to the left of 1.68 is 0.954. To find the area to the right, we simply subtract that from 1. So we get 1 minus 0.954 equals 0.046, and therefore our p-value is 0.046. Now we can take that p-value, compare it to our significance level, and make our interpretation here. So in this example, the p-value of 0.046 is less than the level of significance. And as we know, if the p-value is less than the level of significance, the conclusion is to reject the null hypothesis. So our interpretation, at the 5% significance level, the data provides strong evidence to show that the proportion of males is greater than the proportion of females who agree with the statement, gender equality is better now than it was 50 years ago.